Yes, welcome to DC Economics. So today we are going to look on how we can solve derivative of a derivative or higher order derivative or successive derivative. So the first order derivative of y with respect to x is written as dy over dx. Sometimes we write it as a function of x. So from the first order derivative, when we apply the second order derivative, now is obtained by differentiating the first order derivative with respect to x, and this is written as, now we can write the second order derivative in this form over here. So this will be written as the second order derivative of y in respect of dx raised power of 2 is equal to, now we apply the first order derivative of the function of dx, then we plug in dy over dx, we plug in the first order derivative of the function, and this now is actually denoted as, now we can denote this as the function of the second order derivative, as you observe. So for example, let's go to an example. Now suppose if y is equal to 5x cubic plus 3x squared, then minus 8x plus 2. Now you are required find the second order, the first order derivative, that is dy over dx, that is the first column. Then second, you need to find the second order derivative, that is d raised power of square dx raised power of 2, something like this. And then third, you need to find the third order derivative, that is d cubic y over dx cubic y, as you observe. So solution, the first order derivative will be taken from this equation here, will be equals to, let's take the equation of y, which is equal to 5x cubic plus 3x squared minus 8x then plus 2. Now the first order derivative will be dy over dx is equal to, now apply the derivative on this function. Take 3 times 5, that is equal to 15x raised power of 3 minus 1, which is equal to 2, plus 2 times 3, which is equal to 6x, then minus, take out derivative of this function here will be equals to 8. And 2 is written as constant. Any constant number when you derive it is equal to 0. Let's say we could say here it is 0. So we remain with this function as observed here. Now we apply the second order derivative from the first order derivative of the function. That would be equals to, this is like to say from the first order derivative of the function, that is dy over dx is equal to 15x squared plus 6x then minus 8. It's like to say now from this kind of derivative we may apply the second order derivative, that is d raised power of x squared, as you observe, is equal to 2 times 15 is equal to 30x, then plus, it will be equal to plus 6. Now this is the second order derivative. Now let's apply the hard derivative going on the third derivative. Let's apply the this is the second order derivative, as you observe. Now we could apply even the third order derivative and so forth and so forth. So if we apply the third order derivative of the function, this is likely to be, it will be now, when we differentiate out the third order derivative of this function, this will be equals to, the answer here for the third order derivative will be equals to 30. This is the third order that we've applied, and after doing the results of that when we derivatize. Now after doing so, let's look another example. Another example, if y is equal to x raised power 4 plus x raised power 2 minus x. Now you're required to find out one, the first order derivative, the second order derivative of the function, and last one is required to find the third order derivative of the function. Now from this equation here, y, let's go to now let's solution. Now y is equal to x raised power 4 plus x raised power 2 minus x. So this is like to say now we take out, we derivatize this kind of function here to obtain the first order derivative, that is dy over dx, will be equals to 4x raised to power of 3. We take out 4 times x is 4x, then 4 minus 1, which is equal to 3. Then plus take out 2 times x, which is equal to 2x. Then minus raised to power derivative of x is equal to 1. Now after obtaining this, let's find the second order derivative of this function. This will give out, will be equals to, take out 3 times 4, which is equal to 12x. Then 3 minus 1 is equal to 2. So it will be raised to power of 2, then a plus 2. Now the third order derivative of this function now, we'll consider to take out the dy functions as you observe. So this will be equals to third order derivative of this function will be equals to differentiate this function here. It will be, if 2 times 12 is equal to 24x as observed. So this will be the answer for the third order derivative of this function. As long as we consider the third order derivative of this function, the third order derivative for this function will be equals to, as consider now our dy over dx is equal to function of x. That's to say now derivative of the third order derivative of this function we give out is equal to 24. It will be equals to 24x as observed. This will give out is equal to 24x. So that is how we solve. So thank you. Let you watch another videos, and I welcome you to DC Economics. Once again, don't forget to subscribe to my channel, and tell you bye bye.